So, my name is Maja. I'm a front-end engineer at Airbnb in San Francisco, and I'm going to start this talk with a fun fact, because that's kind of the traditional way we present at Airbnb. So my fun fact for today is that I actually broke my nose on Saturday. So it was fine. I was playing rugby. It was like very expected. But so if you notice these kind of like bruises under my eyes, it's not just the jet lag. It's a bit of the nose. So I'm here to talk to you today about right-to-left languages, and specifically the infrastructure we've been working on to support them at Airbnb. I hope to answer a number of questions throughout this talk. First, why support right-to-left languages at all? Why is it hard to do so? What tools are kind of already available to us out there? And then finally, how we ended up tackling the problem at Airbnb with like a special secret bonus deep dive into our CSS and JavaScript like infrastructure. The takeaway is that I plan to demonstrate the steps it takes to get this screenshot to turn into this. And I hope that you leave this talk inspired to build in the same kind of support into your apps and help make a more connected web, one that's available and accessible to everyone in the world. So jumping right in, before we built this whole new infrastructure, it was important to consider who we were building it for and why it mattered. I'm of course a bit tempted to go back to the title slide and be just like, it's the right thing to do, and walk off the stage and be done with it. But I'll delve a bit more into the details. It's difficult to pinpoint an exact number of languages that are written right to left, but a huge number of people speak, read, and write these languages. Arabic alone is the 5th most spoken language in the world, with estimates from about 300 million to up to 425 million people speaking some variant of it. Couple that with languages like Hebrew, Urdu, Persian, and more, and you easily add another 250 million people in the world who would benefit from a web that readily supported right-to-left languages. Now, since Arabic is the most popular of these languages, we actually have the most data on Arabic internet users, and specifically on the growing digital generation in the Middle East and North Africa. Internet penetration in the Middle East is actually higher than the global average of 51%, sitting at near 60%. Some countries, like the UAE and Qatar, actually have over 90% of the population regularly accessing the internet. And these aren't casual users. 40% of what's been dubbed as the Arab digital generation is actually on the internet for at least 5 hours a day. Now, taking a step back, even if you're not doing business in the Middle East or investing there specifically, Arab immigrants have spread out all over the world. They're an enormous force on the web. 4 to 5% of all internet users speak Arabic, which amounts to about 200 million individuals and is actually the 4th largest language group. The number of English speakers on the web have grown about 600% since 2000. The number of Arabic speakers have grown over 7,000%. This is huge. And what's more, at least 60% of these users say they would prefer content in their own language. It's so much so that there's actually a statistical preference towards blogging and other sort of content creation platforms, which you can extrapolate is because they want that native language content. But only 1 to 3% of like the world's top 10 million websites actually have that Arabic content. And I really think the people in this room are the ones who can move that metric in a positive direction. But for most of our apps, it's non-trivial. So, which begs the question, of course, why is this hard? If the problem was just supporting basic Arabic content, it wouldn't be a challenge. We'd simply align everything to the right and call it a day. But, of course, Airbnb, like a lot of other platforms, has a ton of user-generated content. While our curated text is shown in the user's preferred language, there's a good chance that reviews, Listing titles, descriptions, names will be in a different language, which creates a bidirectional text environment. And, of course, fun fact, even if we could control the language of our content, Arabic, Hebrew, and these other RTL languages are actually bidirectional by default. Numbers are still read left to right, creating a challenge when presenting even the simplest of information. Bidirectional inputs are even trickier. If you have to be able to handle input in every language, that opens questions of directionality in the UI. Do you justify the input according to the page's content language? Do you decide on the fly based on which character the user inputs? What about prefixes and suffixes? How do you address text, numerical, and mixed content? There's a ton of open questions as to how to create the best user experience. When you add a little bit of directional styling, even things like floats or padding that's asymmetrical, that too needs to be mirrored in an RTL context. And finally, iconography and other images need to be taken into account. If the text is flowing right to left, it makes sense that arrows, chevrons, and other images likely need to be modified to point in that direction as well. And this gets you really into the weeds. Like, what about IDs or search icons or check marks or even universal symbols like for accessibility? There's so many icons and images that may or may not need to be flipped. We're left with a ton of questions as we explored the existing standards. And what became apparent is that we'd actually need to allow for some imagery to stay in the default direction, and then we need to flip some others. So, in summary, for a truly comprehensive system to support right-to-left languages, we need to be able to support not only right-to-left content, but also bidirectional content in the same page and sometimes even in the same sentence. We need to figure out how to allow for users to type in content in their preferred language. We need to allow for custom styles to be mirrored, things like padding, alignment, borders, things like that. And we need to have the same allowance for images and iconography. And just in case, we need the ability to opt out of all of these things on a selected basis. So the big question becomes, how do we accomplish all of this with minimal disruption to our existing codebase and our developer workflow? We can begin by assessing the tools that are available to us. The main thing at our disposal is this HTML dir attribute. It's not a new feature. It's kind of the opposite of a new feature. It was introduced to the HTML spec in 1999. And was kind of designed as a one true thing to holistically support right-to-left languages. This means that the browser support is super good. Every browser supports it. But unfortunately, it was built for a very different web. So if we were to time travel back a bit, take a look at a beautiful brutalist Airbnb.com, we'd actually have enormous success just by setting the dir attribute on the top level. Notably, this attribute is designed to automatically flip inline block content and tabular information. So in the simplified Airbnb design, we see that everything is right-aligned as expected. Labels are on the correct side of their respective inputs, and tabular data, like our calendar, or even the grid of experiences, flows in the right direction, which is what we want. One thing to note, though, is that inline information, like our header links, remain in the same order, even with the dir attribute set. This is due to the fact that the content is written in English, and actually, if we translated this, it would flow in the opposite direction. Another sort of weird point that's on this page is due to mixed content. Looking at the prices on our listing cards, we see that the bidirectional algorithm has identified the price as leading the clause. And as a result, in a right-to-left page, that means it's on the right side. If we translated this per person, it would actually be okay. So you can imagine this page in Arabic is pretty good. So our first step in addressing right-to-left layouts is to set this dir attribute on each of our pages on Airbnb. At the same time we set it, it made sense to make that value available to components down the tree so that we could do some customization if necessary. Enter React with direction. So one of my coworkers, Yaniv Zimet, conceived of and implemented this particular library. It follows a basic structure that we've been using a lot for top-level variables at Airbnb, things like breakpoints or loading state or even our internal brands. The library ships with two main exports: a direction provider, which sets the direction attribute on kind of a top-level node, and a with direction wrapper, which consumes that direction as a prop and sends it down to each of its child components. So, in action, the direction provider is very simple. If we start with like a very basic hello world React app, we'd simply wrap the contents and set the direction to either RTL or LTR. Or more realistically, if we support 27 different languages, we'd have some like high-level API that returns the current one and sets the direction appropriately. In practice, if we do nothing else, this just sets the dir attribute on a top-level root node of our app. Once it's set, however, we can leverage its value down the tree by using the with direction wrapper. And this becomes quite powerful. If we wanted to have a very basic step incrementer component with a chevron icon that we can click and move our stepper forward, if we just put the dir attribute on top, you see it works in the right way, and because we've styled these elements in an inline block fashion, it'll even put it to the correct side of our text, but it's pointing in the wrong direction. And if we want to solve this in a reusable way, we'd want to create a direction-aware icon. Let's call it icon chevron next. By default, it returns the icon pointing to the right. But if we wrap it in with direction, we'll get access to that directional context. And we can return a left icon in the RTL context. So this, of course, changes the game. If we reference this new and improved icon and set a direction provider at the top, we can easily have a stepper that works in every language with no problem. So, with these basic tools at our disposal, we wanted to investigate how many of our components would need to be wrapped in with direction and customized according to that value. And unfortunately, the answer was quite a lot. The dir attribute only handles inline block and tabular layouts, and a lot of our pages were styled in different ways. In fact, even the most basic layout characteristics, like the fact that this book it box should be on kind of like the far side of the page, doesn't get fixed by the dir attribute. And we'd have to manually address all of these little style tweaks and spacings and things like that if we didn't come up with a better solution. And we really didn't have the resources to deal with that. So, we started investigating automated options. We found a number of open source projects, including R2, CSS Flip, RTL CSS, CSS Janus, Webpack RTL plugin, and even, I've lost all my slides. And all of these packages came with one major caveat. They're all CSS packages. And we'd been spending the past 2 years moving away from style sheets. So none of these were really helpful for us. Maybe in 2014, when we'd been relying on kind of an internal bootstrap-like framework, but at this time, it wasn't really relevant. I'm gonna go on a bit of a tangent to explain. Airbnb had traditionally been Ruby on Rails, Backbone, Sass style sheet shop. But as we moved to a world of React, the style sheets we had were still associated largely with routes, whereas our components were more feature-based, so they might be shared across multiple routes and across multiple pages. We also had a lot of generic class names that were really hard to track down and grep for, which made it really difficult to determine what component required which style sheet and which style sheets were still in effect. This was like a particularly big one. If you can't figure out if a particular override or style is still being used, that ends up in us sending down an enormous amount of CSS, some of which isn't applicable to the page you're looking at, some of it which isn't even applicable to any page on Airbnb. And this was causing a big performance issue. All of these things coupled together led to incident after incident. I think I sent out 6 individual postmortems related to mistaken CSS style sheets. So we started considering other options. The question we asked was, how do we style React components while minimizing side effects, performance impact, and implicit dependencies? The answer for us, and I will emphasize that it may not be for you, was to couple styles with our components and write our CSS in our React components. The idea of CSS-in-JS had been hot around the web for a while, and there were numerous paradigms out there already. We were personally leaning towards Khan Academy's Aphrodite library for a number of reasons, and ended up trialing it in our shared component library. I'll delve into the basics of how it works. With Aphrodite, the most important thing is the style sheet. Somewhere in your component, you want to call Aphrodite stylesheet.create method with your definitions. It could be on import, it could be deferred to the first render, but that variable needs to be accessible by your DOM elements. Aphrodite, notably, also handles fancy selectors, things like pseudo-selectors and match media queries, and that's a feature that's built on a pluggable selector handler, which will be important to us later. What Aphrodite does under the hood is essentially transpile that style definition object into something it can understand. Notably, it hashes the key of your style and creates a class name for it, and then does any special selector handling to generate the actual CSS. You reference these styles objects on your individual DOM elements using the CSS method. And this, in turn, turns into a unique class name associated with that set of styles. And what Aphrodite does is inject it directly into the page as a style tag. This is great for performance reasons because it's only ever injecting the styles that are actually being rendered to the page. So if you lazy load something, those styles won't be there on first render, which is pretty cool. We also enjoyed the parity of these definitions with React Native styles in particular. But since the greater open source community hadn't landed on a CSS-in-JS solution, and in fact still hasn't really landed on one true solution, we didn't want to write all of our thousands of components using Aphrodite, only to have to rewrite them again in 6 months. So one of my coworkers tried to future-proof this idea at Airbnb with a package called React with Styles. The basic premise of React with Styles is that no matter what technology you're relying on, you always write your components the exact same way. What actually does the under-the-hood legwork of that styling is an interface. And most importantly, you can easily swap that interface out by just changing what you register. We currently have interfaces implemented for Aphrodite, JSS, React Native, and even, hilariously, an interface that turns your CSS-in-JS back to deterministic class names and style sheets, just in case you change your mind. So to write an actual component in this paradigm, you'd start by importing these two functions. And then components are defined the same exact way they always have been. But instead of exporting the vanilla component, you wrap it in with styles. And styles can be defined in a very class-like manner. You can see the parity with how we were using Aphrodite before showing through in this wrapper. You can also easily reference top-level theme variables that you've defined, like color constants or units or responsive sizes, which is pretty neat. And then, because we've wrapped our component, we actually have those styles accessible to us as a prop. We spread them onto whatever DOM node is needed using the CSS method, which again, you can see the parity with how Aphrodite does class names. This method can take conditional statements as well, which is cool if you're trying to do some fancy stuff based on props. And you can even dynamically pass in objects based on prop values or something calculated. This is actually an added feature of React with Styles, and these objects will get converted to an inline style tag instead of a class name, which again, important for later. Coming back to RTL after that lovely tangent, the environment created by React with Styles and Aphrodite proved to be both a unique challenge and a great benefit to how we implemented automatic style flipping for right-to-left contexts. Even though we had to get a bit creative with what was available to us in each of these methods, having this abstraction layer allowed us to iterate and experiment in kind of an isolated playground without touching either Aphrodite or our own code base, which was pretty cool. So, when considering how to flip styles in this environment, we established a handful of requirements that would inform our approach. First, we'd have to handle all directional styles. So things like margin, padding, text alignment, floats, left-right positioning, transforms, everything. Second, this one's really big. We wanted 0 changes to how our developers were writing their components. And we didn't want to have to make any changes to our existing code base. Third, both the Aphrodite-generated sort of like style sheet definitions need to be handled, and those inline style objects that we were dynamically creating on render. And of course, we didn't want to have a huge performance impact on our application while doing this process. So, attempt number 1. You gotta love the number 1 because you know it's not the final one. We noted a few things that kind of like informed this attempt. So, 1, style sheet creation happens on import, not on render. This means that when we call that method, we don't have any access to React context or other variables. The CSS method is a singleton global export. It's not passed down through the props, which means it also doesn't have any access to React context. Objects passed into the CSS method are handled at render time, not on import. That's important. We can, however, assume that all of our apps have a top-level dir attribute set. So we do have that available to us. And, as we noted before, Aphrodite has a built-in plugin system to handle fancy selectors, and we can actually create our own selectors through this process. So, the game plan was to leverage Aphrodite's plugin system to create descendant selectors. Specifically, we would wrap our default styles in a dir equals LTR context, and our flip styles in a dir equals RTL context. So, this is kind of how our basic fancy selector handler would look. You notice we added these 2 new keys that we would be looking at. And the most important part of this is that we would search our generated CSS for anything that looked like a class name. Aphrodite, unfortunately, doesn't give us like a nice object to work with. It just gives us like a string. But we do use regex to find those. And then we'd prefix each and every one of them with an LTR descendant selector or an RTL, depending on which object we were looking at. The effect of this is if this was passed into our style sheet creation method, what would transform into is this output CSS. And so this isn't quite enough to satisfy all of our requirements. If this selector handler was all we did, we'd have to rewrite all of our styles to have these underscore RTL and LTR styles in them. So we wanted to monkey patch the CSS method to do all of this for us. This method takes a list of styles as arguments. It splits them up, so it looks at the Aphrodite styles and inline styles separately. The Aphrodite styles go through the CSS call. The inline styles just get appended to a style tag. And so what we did was create this helper method that would split apart these styles. We relied on a really excellent package called RTL CSS-JS that we've also added a lot to in the meantime. And that handles all of the flipping, identifies which keys are appropriate for which context. And so we dumped out this kind of object output, and then we just passed it into the CSS method. With our custom handler, this actually worked great. And then for inline styles, it was a bit trickier. Inline styles can't have descendant selectors, obviously. So we had to call the same directional style creation method to split those apart. And then if there were flippable styles, we actually created a fake class name for that situation in the same way that Aphrodite does. And otherwise, we just appended the style tag, just as always. Now, we actually had a decent amount of success with just this. We didn't have to change any of our components, and we found that our carousels were navigating in the right direction. Our switch component, which is all CSS, would roll in the correct way. And so it's pretty good. But a number of things cropped up that led us back to the drawing board. For one, descendant selectors don't allow for context switching. And as I mentioned earlier in the presentation, we have a lot of user-generated content. So you might be looking at Airbnb.com in Arabic, but there might be a review in English, and we need to be able to align that properly. Second, descendant selectors coupled with non-directional styles and directional styles, things like border and border left trying to override each other, actually led to a lot of very strange specificity issues that we began exploring and learning about. And then finally, when we upgraded to React 16 in the fall, because we have server-side rendering in our app, we started seeing that whereas previously a client-side render would just win, there were discrepancies between the RTL context on server and client that would sometimes manifest themselves in really bizarre and like undebuggable ways. So we went back to the drawing board. Looking back at our original requirements, we made one small change, which is that we would allow changes to our components as long as they were easily code moddable. So as long as we could make those changes in a manufactured way via script. We made sure we wanted to handle directional context switching, that there were no specificity issues, so descendant selectors were probably out, and that specifically there wasn't a server-client mismatch in some occasions. So our new strategy was to create contextual create and resolve methods based on direction. This, notably, was a bit of a challenge because, as mentioned before, these methods did not have access to context in the beginning. How this would look in our interface, whereas before we would have just one create and one resolve method that would have to handle everything, we split it up. So there's one for the left to right languages, there's one for the right to left. For create, this is super easy. For like, in a default context, we just call stylesheet.create as normal. In the RTL context, we simply flip all the styles with a package and pass that into stylesheet.create instead. Inline Styles is a similarly simple solution. We would just flip the styles. So now there's no specificity issues, there's no like challenges between the two. It's pretty good. And the way we made this accessible to all of our components is before we were creating the style sheet on import. So again, no context. So we deferred it to the first render and then picked the appropriate create method based on directional context. Note, we're assuming that our apps are all wrapped in a direction provider. But again, this doesn't consider dynamically created inline styles, so we also picked our CSS method based on the same context. And the difference now is we pass it in as a prop. So the main change to our components, whereas previously they were written like this, we would now pull the CSS method from our props and call it instead. This is pretty easily code moddable. I was able to write a script that handled almost all of our cases off the bat. And the effect is pretty stunning. With just a few changes to our ecosystem, we were about to get 95% of the way to fully functional, perfect site in Arabic. And so we haven't yet launched. We still have a ways to go in terms of testing across the entire platform, but we don't expect to run into too much trouble. The journey has already gotten us an enormous way there, and we look forward to rolling out these languages in the future and making Airbnb a bit more accessible to people across the world. And if you'd like to learn more, highly recommend checking out our React with Direction package, our React with Styles package, and Kent Dodd's awesome RTL CSS-JS package. And you can always tweet at me if you have any questions. Thank you.